We will be looking at the sine law in this video and more triangle area formulas. And so far in this unit we've only looked at right triangles, but not anymore. We're going to start looking at non-right triangles today. So the sine law can be used with any type triangle, not just a right triangle. Right? So each of the following proportions we're about to go through is an expression of the sine law. Notice that each ratio is made of a pair of items that are opposite each other in the triangle. So if we make a non-right triangle as our example, remember this would work with right triangles as well, but the normal SOHCAHTOA methods that we've gone through are normally used there. So we mainly focus the sine law on non-right triangles. So if I label this triangle ABC like this, and this would be side C across from angle C, side B across from angle B, side A across from angle A. So angle A opens up to side A, angle B opens up to side B, etc. So the sine law is, from using this triangle as an example, it would be sine of angle A over side length A is equal to sine of angle B over side length B, which is also equal to sine of angle C over side length C. So that is the sine law, and you can pick any two. We could put those two together, these two together, these two together, it doesn't matter. The ratios will be equal in any triangle, and this will help us solve triangles later on. So that's what we'll be doing later in the lesson. And just notice that angle B across from it in the triangle is side B, and those go together in the ratio. That's what this sentence right through here is talking about. All right, let's look at the next section. All right, so we know for a right triangle, if we take base times height and divide it by 2, we can get the area of a right triangle easily. So we take the two non-hypotenuse sides, divide them by 2, and that gives us the area. Well, when you're dealing with a non-right triangle, and this would technically work with a right triangle as well, but base times height over 2 is easier. This area formula, K is used for area, can also be used. And they point out here in these notes and right here that you can rearrange this formula replacing A and C and B with various angles and so forth, and still make the triangle work. So what they mean here is instead of 1/2 times it, I usually just put 2 on the bottom. So we could also write it this way. Instead of B squared, we could have side length A squared, and we would need sine of B and sine of C on top, all over 2 times sine of A here. And we could also write it this way. So instead of a B squared or an A squared here, we can use C squared there. So it would be C squared sine of the other 2 angles, so sine A, sine B, all over 2 times sine of C. So these are 3 different area formulas that will still give you the area of a triangle. So depending on what information you have, you can rearrange the formula. That's what they are trying to tell you here. And if you notice in the pattern, the side B is here, so angle B is down here. Sine of the other 2 angles is here. So if we're using side length B, the sine of A and C are here. Sine of that angle B is here. So that's the pattern. If we're using side length A, we put sine of angle B and C up here with 2 times sine of the angle that goes with that side on the bottom, and so forth. So that is the first area formula. Let's look at the second area formula. Okay, and a lot of students like this one better, and we could write it this way: AB sine of C all over 2 instead of by 1/2. It doesn't matter, it means the same thing. So we can also write it this way: the area of a triangle can be AC sine B all over 2. It could be, the other combination we haven't had yet is BC sine of A all over 2, and that would be all the combinations. So there are 3 possibilities for this area formula. Just realize that depending on what you have, if you have side A and B and angle C, then this would be appropriate. If you have side A and C and angle B, this one would be appropriate. If you have side B and C and angle A, this one would be appropriate. So it just depends on which one, what information you have as to which formula is best. Just realize you can rearrange the same formula and get the area. It's not just side A times side B times sine of angle C. You can rearrange it as long as the pattern is the same. You can, depending on what you're given, you can use the area formula here. Also, it's important to note this part. So the area of a triangle is equal to 1/2 the product of any two sides, so A and B, sides A and B, or sides A and C, or sides B and C, all of those combinations, times their included angle, all divided by 2. So their included angle means the angle between them. So if I have this part of my triangle, and let's use this example right here, this would be angle C and side A and side B here. So these two sides and their included angle means the angle between those two sides. So this would be the appropriate setup for this type of triangle right here. If I'm given angle C and I have side lengths A and B, then I would want to use this form of that area formula. Okay, now we're going to apply this new information. So we have triangle ABC. Solve this triangle and find its area. You'll notice that it doesn't say it's a right triangle, so we have to assume that it's not. So we can draw this triangle with almost any shape we want, any triangle shape obviously, and we can label it, I'm going to choose to label it this way, A, B, and C. And now let's fill in the given information. So angle B here is 32 degrees, angle A is 66 degrees, and side length B, so that would be over here, is 19. So now we need to find side C over here, side A over here, and angle C right here, and then find the area. So angle C is easy enough. It would just be 180 minus the other two angles. So 180 minus 66 minus 32 gives us 82 degrees. So side C here is 82 degrees. After that, we can start finding sides. So right now I have side B and angle B, so I know that has to be one of my ratios. So just writing out the ratio here, sine B over side B is going to be equal to, we can find side A first, so we're going to use this, and I'm just going to fill it in, sine A over A. So let's fill this in. Sine of B, that would be sine of 32 degrees over side length B is 19, is equal to sine of angle A, so sine of 66 degrees, all over side length A. So we're missing side length A, so we just cross multiply and we get 19 sine of 66 degrees is equal to A sine of 32 degrees, divide by sine 32, sine of 32, and that will give us A. So let's put that in our calculator, make sure we're in degree mode here, we are. So 19, we'll use our fraction button actually, make it easier. So 19 sine 66 all over sine 32, sine of 32 degrees, and that gives us 32.8. So side length A is 32.8, and now I'm going to go ahead and stick with this ratio because I already have it. So sine of 32 over 19 is going to be equal to sine of angle C, so sine of 82 over side length C. And if you see the pattern here that we used before, we can jump there, but let's go ahead and cross multiply. So we get C sine of 32 is equal to 19 sine 82, and then divide by sine 32 here. And we have side C is equal to that. So I'm just going to copy this down since it's already set up with my fraction button, and I'll fill everything in. So sine 32 is on the bottom, 19's on the front there, and then I just need to change this angle to 82, and we get 35.5 for side C. So there is, the triangle is now solved, and now last thing we'll just find the area. So I'm just going to use this formula here, K, that K is used as the variable for the area of the triangle, is equal to 1/2 AB sine C. So for our example, K is equal to 1/2 times side A is 32.8 times side B is 19 times sine of angle C is 82 degrees. So we'll just put that in our calculator now, and the calculator will come up there. There we go. So 1/2 in parentheses times 32.8 times 19 times sine of 82. We're in degree mode already here, and we get the area is 308.6 square units. So K is equal to 308, and the decimal, let's see, was 6. So 308.6 square units squared. They don't tell me what the units are, so we'll just go with units there. So that completes example 1. So we solved the triangle. It's a non-right triangle, so we couldn't use our normal SOHCAHTOA method. So we used law of sines to find the missing side lengths, and we were given 2 of the angles, so we did 180 minus those 2 to get this missing angle C, and then we used this formula here to find the area. We could have used the other formula. It's more complicated. There's more stuff in it, so I usually stick with this one. Let's look at example 2. Okay, example 2 here. 2 observers are stationed on an east-west line and are 2.3 miles apart. Observer A sees the steeple of the old church with a bearing of north 47 degrees east. Observer B reports a bearing of north 70 degrees west. How far is the church from B? So they're on an east-west line like this. So we'll put observer A here, observer B here. They're 2.3 miles apart, so that distance is 2.3 miles. And observer A sees the steeple with a bearing of north 47 east, so that would be back this way, north and east. Observer B sees north 70 west, so that would be back this direction. So we'll make this C for the church steeple, and we need some due north lines on here so we can apply our angles here. These are the survey type angles. So observer A north 47 east, so this would be 47 degrees right here, this angle. And this angle over here for observer B is north 70 west, so that would be 70 degrees there. Remember that these not navigational, but these survey angles are measured off of a due north line. So that would make this angle 90, that's 90 right there, so 90 minus 70 is 20 degrees. And this one would be 90 minus 47 is going to be 43 degrees. And now we can go to work on that. So it says, how far is the church from B? So we're looking for this side length right here. So let's see what we have. We have angle A and angle B. We have side length C. So that means that we really should find the angle for C here so that we can set this up. So angle C would be 180 minus 43 minus 20. So angle C is 117 degrees here. So set up our law of sines. I'm going to use this. Sine of angle C over side C, because I have angle C and I have side C, so you need a complete ratio. So I have that one. And I want to find this side over here. So this would be side A. So it would be a lowercase a. Side A. So sine of angle A over side A. So those two need to be equal. So sine of C would be sine of 117 degrees over side length C is 2.3 is equal to sine of angle A, so sine of 43 degrees over side length A, which is the missing part. So cross multiply, we get A sine 117 equals 2.3 sine of 43. Solve for A here, so we'll divide by sine 117, and we get side A is equal to that right there. So slide this over and clear this out. So we get 2.3 sine 43, do this in multiple steps, all divided by sine 117. The bell just went off there, so I'll have to mute that out. And we get 1.76. So it is 1.76 miles from B. The church steeple is 1.76 miles from observer B, where he or she is looking. All right, that's it for this video, and that's it for this lesson.